Okay, for this lesson we're going to be creating scale factor. Now this is just like when we were trying to figure out whether two figures were similar with a little twist. So I will start with just saying that this isn't a very difficult idea, but it does take you paying some attention. So let's say I have two rectangular figures. I'm going to go ahead and make the statement they're similar, but we still want to be able to test this. Well, that's the same thing as saying, well, I want to know the scale factor of this. Now, notice I didn't put any measurements on the opposite sides, because they actually share the same measurement as its counterpart. So we don't actually have to carry it forth, because the rectangular, the parallelogram, opposite sides have the same measure. So take my original figure and I place it underneath the old. I keep saying we're going to do new over old. It's just it's consistency that allows us to get these things right. So I look at the corresponding pieces. I take the sides that actually match up to each other. So this side and this side match. So I'm going to put the 4 over the 8. And we know that that reduces down to 1/2. So that's telling me the scale factor is 1/2. Now I made the statement that these are similar figures. But like I said, this is just the same thing as saying I'm testing to see if they are similar. So how do I actually draw? What if I was only given one figure? So let's just have a nice little triangle. I have a triangle and I want to actually create a scaled model of this. And so let's give it some dimensions. And obviously this looks like an equilateral triangle, but I'm going to say that it's not. And I want to apply the scale factor. Remember, I'm just abbreviating that. That's just scale factor. I want to apply the scale factor of 1/3. Well, what this means is whatever figure I have now, I can say what the scales are. So I'm going to go ahead and give this a label. And I want to say I want to try to create triangle DEF. So I'm just going to go through and I'm going to multiply every piece by 1/3. And that's all I have to do for scale factor. I go through each part of the dimensions and multiply by 1/3. So I'll take 20 times 1/3. I get 6 2/3. You might have got 6.6 repeating. It's the same thing. I just switched over to the fraction. 30 divided by 3. It's going to give me 10. And 40 times 1/3 is going to be 13 1/3. So this is actually the new dimensions for a triangle that we have created. D, E, F. So I'm going to give you a triangle to try out on your own. And I'll just hand draw it. So I have the following triangle, 5, 7, and 9. And we're saying we're going to apply the scale factor of, let's do 5/3. A, B, C. So I want you to create triangle DEF, and I don't really care if the actual size is appropriate. I'm more concerned with, are you getting the correct measurements? So I want you to find me triangle DEF's measurements. Now, I've been nice on these and haven't like flipped the triangle around. You have to watch for that. The triangle's orientation might be turned upside down, might be backwards. Watch for those. We gotta still pay attention to corresponding sides. So if you would pause this and then work it out. Okay. If we're proceeding with the video, I want you to just make sure you bring this triangle in to show evidence that you have watched. There is a second video for this, but I am going to stop right now and we'll continue for the next lecture.